Hello, ladies and gents. My name is Amber Koopman, and welcome to my Fundamentals of Physics podcast. We're going to sidetrack here for a little second while I throw a scenario your way. Picture this. A family is driving down the highway on their way to, I don't know, let's say Disneyland, because everyone wants to go to Disneyland, including me. That's not important. Anyways, in the back of the van, the younger brother of this family is playing the "I'm not touching you" game with his sister. As you can see, she is beyond annoyed now, as we all would be. But let me assure you, it could be worse, for you see, the game could actually be played like this. Notice the hand-to-face contact? Very bothersome indeed. Okay, enough of that for now. Back to the podcast. You're probably thinking, after that pic, wow, this chick is insane, and the lack of sleep due to her crazy school schedule has obviously fried her brain. But let me assure you, this is not the case. I hope. So let's just sit back and get cozy in the chair you aren't actually sitting in and listen up, because today I will be explaining the mind-boggling notion that even though we are surrounded by and use many objects in our daily lives, we never actually touch any of it. So, allow me to begin by explaining a few basic concepts you will need to understand in order to get what I'm saying. All the things in the universe, living or not, are composed of matter, which is just a fancy word for stuff. That stuff is in turn composed of dum-dum-dum, atoms, woohoo, atoms, yay, they're the bomb, sweet! An atom is composed of three particles: protons, which are positively charged, neutrons that are neutral, and electrons that are negatively charged. The protons and neutrons are located in the center of the atom, and they form the nucleus. The nucleus is where all the matter is located. And remember this, because this is very, very, very important. And orbiting the nucleus are the electrons of the atom, and I'll tell you a bit more about them after I explain just how far electrons are from the nucleus, using an example we learned in class, because trust me, this is also important. Take the nucleus of an atom and blow it up to the size of a football. Place that football on the 50-yard line of a football field. The electrons for this atom would be way out in the end of the parking lot, partying with all the fans at the tailgate, eating a hot dog probably, I don't know. So, in conclusion, the electrons for all the atoms are very far away from the nucleus, but because of the microscopic size of the atom, it does not seem this way. Now, back to the case at hand. With all the charged particles in the universe, like charges repel and opposites attract. Because of this, all electrons create an electrical repulsion, known as an electric force, and that prevents atoms from getting too close to each other. For example, keeping the atoms that make up your body from getting too close to the atoms of the chair you're sitting in. And like I said, this is because like charges repel, and since all electrons are negative, the negative charges from the chair are going to repel against the negative charges from your body. So, and along with the electric force, the atoms which are moving, so the electrons which are moving as well, create another type of field that repels, known as the magnetic field. Both the electric force and magnetic field occupy the space around us and are constantly repelling like fields and attracting opposite fields. Given that, let's head back to the scenario from before and take a look at an exaggerated view of what I'm talking about. Notice the brother being repelled by the sister's magnetic and electric fields? In conclusion, because of the repulsion caused by like charges of an electron, electric force, and magnetic fields, and the distance between the electrons and the nucleus, we are never actually touching anything, because we never touch the nucleus of an atom, and that's where the matter is located. Hope that didn't freak you out too much. Bye!